Okay, so I'm in Hong Kong. Tomorrow's my interview. This is my room. I'm in my hotel room doing a question. This might be one of the last videos I record, but let's get right into it. So for this one, I'm going to be creating the game tic-tac-toe. A tic-tac-toe game is generally played on a grid with size n by n. It's played by two players, and a player can win. The game ends when a player has a full row or column or a diagonal or an anti-diagonal of its own symbol, or if there are no more valid moves to play. For the tic-tac-toe game, I'm thinking of having a boards class, and this board is like a physical representation of the board. It'll literally keep track of the X's, the noughts, and crosses. We'll have the players, so two players, and each player we'll have one player class and have two instances of it. And the player like literally just has a symbol, and then we'll have the game state, which manages like placing it places the noughts and crosses on the board, and it checks to see if the game should be done or not. So if that sounds fine, the first thing I'm going to create is the board, so class board. And then let's create the init for this, the init thunder method, not the constructor, it's just the init. And let's say it's going to take in a size, which is going to be an integer. And this is going to return none, as always. So we'll do set.size.size, but then we know for a tic-tac-toe board, the length of the row and the length of the column is the same. So we'll do self.board. And then we can use a list comprehension here. So we'll do the inner list first. So we'll fill out one list. And then what I want to do is I want to do a string of a dot. This is going to mean nothing has been played here. Like there's been no noughts or crosses here. So for underscore in range size. So what that does is it gets one list. It's going to populate one list with how many amounts of sizes for dot 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 dot. So it's going to be one row complete. And then for the outer one, I'm going to do this for the same thing for underscore in range size. Now what this is going to do is it's going to copy that one row for the amount of columns. So, but then because we know the rows and columns need to be the same length, this is going to create a list of lists. So let's actually do some writing for that so that we know it's going to be a list, which has a list inside, which has a string inside. So from typing, import list. So I think that's all I can think of for now for what we need to do board. We might come back to it later. But another API that we might need for the board is we might need I'm just thinking before we do a place, before we need a place, we need to see if a move is if a move is valid. So we'll do def is valid move. We're going to take in itself, and then it's going to take in the row, which is going to be an integer. It's going to be taking in the column, which is an integer as well, and it's going to return a bool, either a true or false. We just haven't returned anything yet, that's why it's complaining, but that's fine. So one of the obvious rows and columns that we need to see is that it needs to be greater than 0. So it needs to be greater than 0. Greater than or equal to 0, actually, but it has to be smaller than self.size. This makes sense because we don't want to place anything outside of the grid, and we don't want to, like, before 0, like -1 row, like, that doesn't really make sense, and we don't want to place anything that is more than the grid in the row or column, and this goes for the same for the column as well. So we can simply write that here, or call self.size, then we can simply return false. Another state that we might want to check is that if something has already been placed in a square, we don't want to overwrite that. If someone's already played an X in one square, we don't want the other player to come and say, actually this is a cross. Like, that doesn't make any sense. So we need to check for that case as well. So if self.board row call is not this means that something else has been played there. We're going to return false as well. Else, this should be good to go, and we can return true. So if valid move, so we check if it's a valid move. If it is a valid move, then we'll be placing it in the board. So do def place. I'm going to take it in a row, which is going to be an integer. I'm going to take in the column, which is an integer as well, and then we're going to take in a symbol. And this symbol is either going to be a nought or a cross. And then for this, we can return bool for true if it has been placed, or false if it hasn't been placed. I think it's good to return a bool just to let people know of our cases. So first thing we need to check is if not is valid move. So if it's not a valid move, pass in the row and the column, then we're going to instantly return false. Else, this means that it is a valid move, and then we can update the board. Self.board row column is now going to be the symbol. And then we can return true after that. So that's how place will be adding a valid move and a place into the board. One thing we can also do in the board is we can check if this player has won or not. So, has won, self. Let's say we're going to take in the row. I'm just thinking, right after we do a place, it makes sense to check if someone has won right after they do a place. Because after they place, that changes the game state. And then the symbol. So we'll be taking the same things as the place, and then we'll be taking it, outputting it as well. Now for this, we can have we'll have 4 different cases. We're going to check the whole row, we're going to check the whole column, and we're going to check the, I'm going to call it descending diagonal and the ascending diagonal, just so that we can understand it easier. So let's go through the row. So I think there's like an API called all, return true if bool is true for all values in the iterable. So if self.board okay, let's see. Okay, you know what? Since I don't know how to do that, I'm going to do it a little bit simpler way, I guess. So in our board, we have it as that the rows are going to be the first row, right? So let's get that row that we're going to be looking at. So the row, row array is going to be self.board from the row. Let's see, is that how it works? Yeah. Now for I in row in range row array. Wait, this should be a list, right? Yeah, it's a list of strings. So for I in row array, if I is like a bad name because that's the index. So we do if element is equal to symbol, it's not equal to symbol. So we're gonna instantly return false. Else, yeah, this is right. Else we can return true. At any point, if it's true, then we can return true. Okay, now we actually have to do another way. That we're gonna check if element equals symbol, then we're gonna continue. Actually, let's have a flag. Yeah, I think having a flag is better. Winner, we'll set it to false. Yeah, so if any point it's not equal to the symbol, yeah, if it's not equal to the symbol, we'll not do anything, we'll just break out of it. Else, if we get to it and it's all true, then we'll set winner to true. Actually, let's see how to use the all function. Oh, wait, what? Okay. It's literally just my list. So I have a list, and x equals all of my list. The all returns true if all items in an iterable are true. So if self.board row, and wrap this in a all. Right, let's see. Okay, so it's going to be all if okay, so if le equals symbol for le in self.board.row, then we'll return true. In another case, is if all le equals symbol for le in self.board. So it's a bit harder for the column, right? So let's say we're looking at the first column. What's the row? The row is going to be wait, Wait, does this one even make sense for this? If all LE is equal symbol for element in self.board.row. Yep, so this looks, yeah, that makes sense. That just looks at all of the elements, so that one works fine. But how do we just get, like, that's like a horizontal slicing, that's fine, but how do we get the vertical slicing? So that's a bit different now, isn't it? So let's see it. Okay, since I clearly don't know how to use the all function properly, let's just go to do a normal for loop. So let's look at the rows first. So for I in range self.size, this will iterate through the row. If self.board row, so for this row, we're going to be looking at the columns, is not equal to symbol, then we're going to break. If it's not equal to the symbol, we're going to break. Right? If it doesn't. Wait. Right? Yeah. Does this make sense? Yep, looks good. Let's do the same thing for the column. We're going to have I at the front here, and then column in the back. And then same thing here, I here, and then column in the back. Now, for diagonals, there's only one case where a diagonal will win, and if it only goes through the middle. So let's go through the middle. Let's go through the middle. We don't have to check this all the time. There's only one case where we need to check this. And if the user has played, no, we need to check this all the time. Yeah, we need to check this all the time. Okay, so let's think about the diagonal. So the only the diagonal that we need to see is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So for I in range self.size, we can check it. If I equals, so if we're on the last like bottom right here, and self.board I is equal to symbol, I'm going to return true. Elif if self.board I is not equal to symbol, we're going to break out. And this is going to be the descending diag. Now let's look at the ascending diag. So the ascending diag will start from, let's say, we'll start from the nth row and the and the 0th column, and then the nth minus 1, and then the 1th first column, and all the way blah 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 until we get to the inverse of what we have at the start. So it's going to be 0 and then n. So we can still do the same for I in range self.size. And then we can still do if I equals self.size minus 1 and self.board. So this will be at the very top right. Self.board where this should be 0 and I should be the max equals symbol. No, it should be, yep. Yep, row 0, last column, that's right. Yep, we're going to return true. elif self.board. Let's see. So that's the last case, but how do we get to the first case? So when I is 0, let's think about this. Break, and the end we can return false. So let's think about this, yeah? Let's think about if elif self.board. So it's n and then 0. So if I is 0, wait, and then it becomes n minus 1 and then 1. So when this goes up, okay, so this is going to be self.size minus I, and this is just going to be I. Cool, so this looks good for a has one function for our board. Right, am I recording? Yeah. So let's see, I think those four is a good start to what a board might look like. Let's see, so we have the actual board, we see if it's a valid move, we place it, and we see if someone has one. We could probably do like a string representation to see like the state of the board right now, but maybe that's something we can do later. Let's go on and create the person class. So we'll do the init thunder method for this as well. Make sure it's called thunder method. Init thunder method. Yeah. And then we're going to take in a name. Let's say it's a string, and let's say it's a symbol, which is also a string. We could do an enum for the symbols, for a note and a cross, but I'm just going to keep it as a string for here. So self.name equals name, and self.symbol equals symbol, where the symbol might be an X, or might be an O, like that. Yeah, I don't think the person class needs anything more like that. Let's create the actual game. So when we first create the game, let's say we're going to take in person 1, which is going to be a type of person, and then person 2. It's more of a player, I guess, than a person. Person 2, which is going to be a type of person as well. And then this is going to output, well, the init's not going to do anything. Same thing here. This one's pretty unnecessary, but it's good to have, I guess. We're going to have the board. So we're going to have a new board. Oh yes, we also need to print in the size, which is going to be integer. Let's default to 3 if the person has not specified anything. The board, yeah, and then we have self.players. Let's have a list of per layers, person 1, person 2, and then we can iterate through who's playing. Self.players. A good way to iterate is we can have a count. We can have a turn count. So it's going to be 0. And then we can do 1 minus 0, which is going to be 1, so we'll go to person 2, but then we do 1 minus 1, and then back to person 0. So let's do that first. Switch turn self. It's not going to take anything else. It's not going to output anything. So it's just going to do self turn equals 1 minus the current value of self.turn. Cool. Now let's do our main loop, which is called the game. It's not going to take in anything, and it's going to output. Let's say it outputs a string, and the string is going to be output person 1 as 1, for example. I'm just complaining because we actually have not output anything. Okay, we're getting there, okay? Let's have it in a while loop, while true loop. Or we could have like oh, there's one more thing that we need to check for the board. It's has every square been filled. Okay, an easy way to do that is just have a counter of how many stuff has been played. So every time we place one, we're just going to append to the counter by 1. Then we can have a method def no more moves. Has no more can move self. It's going to return a bool, and then it's going to return the opposite of self is this length of self.counter the same as self.size times self.size. So if it is the same, this means we can't move anymore, so it's going to return true. It's going to return false. Yeah, it's going to return false. It's going to return false. It's going to return false, right? It's going to return false. Yeah, it's going to return false, meaning that we can't move anymore. And then we can actually do it here. So while self.board can move. So while we can move, we're going to continue to play this game. So while we can move. So while we can move, let's print out, let's do an f string. It is self.players, self.turns, move. Actually, we can do this into a input. And they're gonna input x, y. So we have to split this by a comma. Yeah, cool. So if the move, and then we're gonna check if self.board, row call, we're gonna be splitting it. Self.board dot, and we're gonna do place. I should make this a private method because we will be calling inside here. Self.place, and then the symbol is going to be. We'll actually find the player as well. Let's just find the player here because we might need to use it again. Self.turn. It is. I just realized we're just passing in the whole object, so that's not going to work. We're going to pass in player.name. And then for this one, we're going to player.symbol. Yeah, we'll just cast this to an integer as well. That's like a valid type. Thank you. So we'll place, after we place, we're going to check board.has one. Okay. I guess I could see why this might be a bit redundant. But we just need to see, like, this is better because this only checks the row, the column, and the diagonal. Well, it checks the diagonal all the time, actually. So maybe we don't need to do the diagonal. We should only do the diagonal. Yeah, we should. Yeah, let me change that. We're only going to check the diagonal. If row is equal to the column, then we'll check the diagonal. And what about this one? It's going to be the opposite. So if... Let's see, what... Like... So if we've played on n or 0, n0, n minus 1 and 1. So it's going to be if row minus column. Yeah, if row minus column is equal to column, then we'll be checking it here. Does that make sense? If row minus column. So let's say he's played on 0, 3. Let's say he's played 0, 3, then we need to check it here. So row minus column is going to be -3. Okay, it would be column minus row, because column is always going to be greater. No. What if it's 3, 0? And this is -3. A better way to check actually is that we can see n plus 0 is n. N minus 1 plus 1 is n. 0 n is n. So it's always going to be if column and row add up to the size. Size minus 1. Then we'll do the check for this one. Yeah. There we go. So if 1. So if someone has 1. Oh. Yeah, so if not, then we're going to continue. So it's going to do that again. It's going to just say it is 1. And then here we're going to print out with an f string player.name as 1. We can break out, and no one is the wiser. But if the while loop prints out, that means it's a tie. Cool. Why are we still complaining? Do I need to return something here? No. Is that really why? Okay. But that looks like a good game. Let's see. Let's write some test codes for this. Right, we need test cases for this. And let's see what test cases they might hook up. Alright, so I asked DeepSeek to make me some test cases. Let's see. Still making some. It's still writing the test cases out, so I guess it's a really comprehensive test case, which is good. Definitely, you know, I do want to catch all the edge cases that I can, some stuff that I might not have seen. Okay, cool. Now let me paste those in. And let me run it. Okay, so there are some issues. Some pass, let's see. Line 16 is not. Oh, okay, we can't do that. We gotta do, this is how we do a string check. Okay, is that better? No, not really. List index out of range. 172 has 1. I'm pretty sure I need to do 1 minus more here because, yeah, that's not gonna be a proper one. Cool, okay. Now this is just some errors. There's no more errors, it's just some logic issues. True is not false. Let's say 2x2 board. So this should be false, but it keeps returning true for some reason. Let's see. So I've made 4 moves. So it's a 2x2, so there's 4. And then I've made 4 moves. I've made 4 moves. Place. Self-decide. Let's see. Let me just fix this first. Okay, so board dot can move. True is not false, so it should be returning false, but it's returning true. Why is that? Place. Right. Is it not place? Or dot place. Yeah, when I place, we should be adding to the counter by 1. Right, yeah. Why are we not doing that? I don't think this is actually appending. It's actually increasing. Wait, do we ever get here? Oh, wait. Is it because of this? Okay. So we check if it's a valid move. So for it to be a valid move, no, this is right. It needs to be smaller than the size. It needs to be bigger than or equal to 0, because it can be the 0th exit, but it needs to be strictly smaller than the size. It can't be the same as the size. And if it's not that, it's going to return false because there's already something else in it. Wait, so if I do it like this, does this ever get here? Right, we never really. Just always go to false here. There must be some issue here. Oops. What does it fail on? It's on the top. Fails on the top. Okay. Wait. This is obviously wrong. What am I doing? No, I gotta check if row is smaller than. Wait. So, yeah, if... What? What am I doing? Okay. Or row is bigger than or equal to. Yeah. Or 0 is bigger than smaller. Or column is bigger than or equal to the self.size. Yeah, there we go. Okay, that's much better. Can't believe... What was I thinking? Board has 1. Let's see, 224. I think 0 has 1. I think O has 1. It's a bug. Which one is it returning true on? Returning true on the bottom. Wait, is it? So 0, 0 is an X. Well, 1, 1. 1, 1 is an X. Wait, what? They have one. Have they not? This is a bug in the code. This should be true. There we go. Yeah, they have one. Test has no one. Has one, no win. Has one, no win. Okay. Yeah, cool. So that is the tic-tac-toe class. How long did that take me? 37 minutes?